In this project, I will demonstrate how to use speaker module with FPB-RA0E1 board to generate musical tune. For this project, I am using FPB-RA0E1 board, groove base shield for Arduino interface, and a speaker module. Attach groove base shield on FPB-RA0E1 board, then attach speaker module with D7 of Arduino interface. According to this quick start guide document, on FPB-RA0E1 board, D7 of Arduino interface is connected with P103. Now we will recreate this example in eSquare Studio. Open eSquare Studio and click on file icon, then select new, then select Renesas C++, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on next button. Here from this drop down menu, select FPB-RA0E1 board and then click on next button. Here select executable and no RTOS option, then click on next button. Here select bare metal minimal and click on finish button. Now IDE will take some time to generate your project. After project creation, open FSP configuration file. Now IDE will take some time to generate your project. After project creation, open FSP configuration file. Then open stack tab. Here a default GPIO stack is already configured according to FPB-RA0E1 board. Now click on pin tab, then expand P1. Here select P103. Now we need to change the mode for P103. Initially it is configured as input pull-up mode. Change this to output initial low mode. After that we don't need to change anything further. Click on generate project content, then open hallentry.c file. First we need to declare base tab, melody and note duration. Now we will use these two functions to create a output tune on speaker module. First I will define play melody function. First we need to get number of notes defined in melody array. Now use for loop to iterate through each note. For each note we will play melody for its respective duration. Now I will define the play melody function. Now you can calculate period and cycle using these formulas. Now use for loop to iterate through each cycle. In each cycle we need to turn on and off speaker pin. For this you can take help from developer assistant tab and developer assistant tab and drag and drop pin write function call in hallentry.c file. For pin name, you can use this pin name defined in FSP configuration file. For third argument, we can use BSP underscore IO underscore level underscore high variable to turn on the speaker. Now use RBSP software delay to introduce delay according to the base tab array index. Now use pin write function to turn off the speaker pin. Now again introduce the delay using RBSP software delay according to the base tab array index. Now I will build my project to check for any error in my source code. I got one warning related to variable conversion in melody function. We can typecast this integer variable to uint8 underscore t variable. Now go to hallentry function and declare a while one loop here. Now in while one loop you can call play melody function after every 2 seconds. Now click on your project name, then click on hammer icon to build your project. Now I will explain this program in detail. The base tab array here represents the 7 musical notes A, B, C, D, E, F and G. Function of the melody array is to create the Twinkle Twinkle Little Star tune. For this tune we need to play musical note or base tab array with the index defined in melody array. Note duration array will define how long the base tab musical note will be played. To get the number of notes in melody array, we can divide the array by the size of integer as array is defined as an integer array. Now for every note in melody array, we will toggle the GPIO pin according to play melody function. We are using square wave for speaker module. Now we will multiply the base tab note with 2 to get the period for the high and low part of the square wave. Now we will calculate the number of cycle and then we will toggle the GPIO according to the base tab array to get Twinkle Twinkle Little Star tune. After a successful build, right click on your project name, then select debug as, then select Genesis GDB hardware debugging. Now click on switch button to switch to debug perspective. In debug perspective, click on this resume button twice. Now you can observe the tone generation by FPB-RA0E1 board using speaker module. In this waveform, we can observe 14 melody notes, which are musical notes from base type array with the duration specified in note duration array.